Hey ANPers, this is Dr. Jones checking in. This is ANP1 Lecture Test 3 video, checks notes 4 for page 5. So we are talking about bone cells in this video. There are 4 different kinds of bone cells. So first we have osteocytes. Osteo means bone, cyte means cells, so these are mature bone cells, and they are found in the lacuna. So the osteocytes in lacunae, this is what they look like. Lamellae are layers of bone matrix. And there are a number of different kinds of lamellae. You've got concentric lamellae in the osteon, interstitial lamellae in between osteons, and then circumferential lamellae around everything. So we'll talk about that. And then I typed this in. I wonder if that's important. Osteons are the structural unit of mature, compact bone. That really reads like a test question, doesn't it? Canaliculi, we didn't talk about canaliculi. Canaliculi are little canals, and these are little narrow, they're passageways in the bone matrix for little finger-like extensions of the osteocytes to communicate with each other. Because the blood vessels all run in the central canals of the osteons, these canaliculi are how the osteocytes pass nutrition along to each other. So they pass the nutrition out from the blood vessels to the far-flung osteocytes, and the wastes go back in the other direction. Okay, next cell is the osteoblast. A blast cell is a builder cell. A blast cell is a builder cell, and osteo means bone. So these are the cells that build bone. But a caveat, they only build the organic portion of the matrix, and the organic portion of the matrix is collagen fibers, and it's called osteoid. And building it is called osteogenesis. Genesis means the beginning. So this is new bone, making new bone, synthesizing bone, the process. It's also called ossification. So ossification or osteogenesis, make new bone matrix. The new bone matrix is the osteoid, except the osteoid is just the organic part. So just collagen fibers. Okay, mostly collagen fibers, but all right, and then the osteogenic cells or osteoprogenitor cells. A progenitor is what makes something, genic is like Genesis, the beginning. So the osteoprogenitor cells are the stem cells that divide to make new osteoblasts. Osteogenic cells make new osteoblasts. A blast cell is a builder cell. And then the osteoclast. A clast cell is, in the voice, the destroyer. Okay. So the osteoclasts are the destructive cells. They are giant multinucleate cells. And they make, just a second, I got caught up in my brain on the destroyer. Like, should I have leaned in more, emphasized it more? All right. So osteoclast, giant multinucleate cells that contain acids and proteolytic enzymes. Have we talked about proteolytic enzymes? I think we did. Proteolytic. So proteo means protein, and lysis is a loosening of. So these are enzymes that digest proteins. So what do you have in proteins in the bone matrix? The collagen fibers. What else do you have? You have calcium salts. And what dissolves calcium salts? Acids. So proteolytic enzymes and acids. And of course, enzymes are themselves proteins, as a reminder. Okay, so when you are low on blood calcium, and you do require a certain amount of blood calcium, or your skeletal muscles seize and your heart quits beating. So both are bad. Ooh, what's the one skeletal muscle that we really don't want to seize? The diaphragm. How do you spell diaphragm? That's right, D-I-A-P-H-R-A-G-M. You got it, the sneaky silent letter. Okay, so you don't want your diaphragm to seize because then you're not breathing. And you don't want your heart to quit beating because that's about as good as not breathing. Okay, so the osteoclast will actually dissolve this bone matrix with acids and the proteolytic enzymes to eat the collagen fibers, and then they release the calcium into the bloodstream. So better to have holes in your bones than, not breathe or your heart not beat. Oh, and the process is called osteolysis or resorption. Osteo meaning bone, lysis is a loosening of. So it eats holes in your bones. That's what osteoclasts do. And now the two main functions of osteocytes. Where do osteocytes go? The two main functions of osteocytes. Number one, maintain the protein and mineral content of the surrounding matrix. And two, participate in the repair of damaged bone. Why is the balance between osteoblasts and osteoclasts, so important? What happens if the osteoblasts are more active than the osteoclasts? Well, the osteoblasts build bone matrix, and the osteoclasts destroy bone matrix. So if the osteoblasts are more active than the osteoclasts, then you're building more bone than you are destroying, and you're growing thicker, stronger, more resilient bones that are less likely to break. If, however, it's more likely the case, the osteoclasts are more active than the osteoblasts, then your bones become steadily weaker and thinner, more brittle, and easier to break. So, and then now we draw the bone. Okay, go back. We're going to draw this. So let's whiteboard it. White screen it. Excellent. All right. Up in a corner and out of the way. Good, good. Okay, so we need to draw two osteons with central canals. So osteon, osteon. I'm going to go ahead and draw three osteons. Osteons. So let's label one, this whole round thing, osteon. Okay, and it says they need central canals. Sorry, I'm writing with a mouse. It takes a second. There we go, central canals. And they need their concentric lamellae. We need a different color for that. I'm feeling aqua. Okay, cyan, perfect. So the concentric lamellae are like concentric circles, which is effectively a target. Okay, that's about as much accuracy as I can draw with that. If I can draw it, all y'all can draw it. True story. Okay, so let's label these concentric. And this is both lecture and lab material, so this is need to know either way. And then lamellae is L-A-M-E-L-L-A-E. So A-E is plural, and A without the E will be the singular. So concentric lamellae. And then we have osteocytes in the cunate. Do we have brown? We don't. Oh, we're going with magenta. Snap. So let's draw some little like flax seeds here. Okay. So these are osteocytes. And they are in lamellae. The lamellae are the same size as the osteocyte, which is different than the chondrocytes in lamellae, where the lamellae were bigger than the chondrocytes, and you could see the lamellae as a separate space. I'm sorry, lacuna as a separate space. Wrong word. And again, AE is plural, A by itself is singular. Okay. And these osteocytes have little lines. It's kind of easiest just to draw them as like eyelashes, but like fake eyelashes. I was at the store, I saw magnetic eyelashes. Like you paint like magnetic stuff on and then the eyelashes just like stick to you. There's so much crazy stuff now. My daughter does the makeup stuff. We bought her new lipstick the other day and I was like looking at all the colors and overwhelmed, and I was like, honey. So I made my husband pick out the colors because I'm not an artist. Colors aren't my things. So. Okay, so I drew all the eyelashes, and what are the eyelashes? Canaliculi. Canaliculi are the narrow finger-like extensions, eyelashes, from the osteocytes that touch each other and exchange nutrients and wastes, because the blood vessels, now I need red and blue, red and blue. The arteries and veins, the blood vessels are in the central canal. So how do all these far-flung osteocytes get nutrition? Through the canaliculi. They're little bitty straws of finger of the cell that reach out to each other and bring life-sustaining nutrients and take away wastes. That was not everything we draw. 2 osteons, we did 3, with central canals, concentric lamellae, osteocytes and lacunae, and canaliculi. Now add a periosteum. Okay, we'll outline the whole thing with a black periosteum. S-T-E-U-M, periosteum. Okay, and deep to the periosteum, what color have we not used? Yellow doesn't show on the white. White doesn't show on the white. We used green. Okay, we're going with blue. This is why I don't draw rainbows. Hey, if I can draw it, all y'all can draw it. All right, it didn't work. Okay, so these are circumferential lamellae. Did we talk about the circumference of a circle? If you measure halfway across, that's a radius. If you measure all the way across through the middle, that's the diameter. But if you start at one point and measure around the outside, that's the circumference, because it goes all the way around the circumference of the circle. And so these go all the way around just inside the periosteum. So these are circumferential, E-R-E-N-T-I-A-L. I'm an oral learner, so I spell out loud, or I say it in my head. I can do it quietly out loud, but I have to hear it, even if I'm only hearing it in my head. Lamellae, L-A-M-E-llae. M-E-L-L-A-E, and I made it plural, so I will point to more than one. There you go. Circumferential lamellae go around the circumference of the circle. And now we need to add our interstitial lamellae, which I think are going to be red because that's the only color that's left. So the interstitial lamellae are outside of the osteons, in between the osteons. Just like the interstitial fluid is the extracellular fluid outside of the cells, in between the cells. Interstitial, S-T-I-T-I-A-L-L-A-M-E-L-L-A-E, plural, because I pointed to more than one. Okay, so the interstitial lamellae are the remnants of remodeled osteons. Test question. Excuse me, some in my throat. So these interstitial lamellae are the remnants of remodeled osteons. So the bone remakes itself all of the time. We'll talk about details later. And the old osteons, what's left of them after a redecorating, are the interstitial lamellae. Okay. All right, so that was page 4, which is video 3, 5. I have lost track. There we are. Video 4. Page 5. My page numbers are off. And we drew the bone matrix. And again, you need to be able to draw this off the top of your head, spelling everything correctly for both lecture and lab. So thank you as always for tuning in. It's good to virtually see you here. This has been Dr. Jones with A&P1, Lecture Test 3, video I've forgotten. Dr. J out.